This is our third talk of the CubeSat webinar. Our speaker today is Professor Sheng-Long from National Taiwan Ocean University. And Professor Gao will be speaking to us about some applications of small satellites to the maritime industry. So Professor Gao, please go ahead when you're ready.
Thank you very much, Mr. Roland. Ladies and gentlemen, I'm very happy to be here for reporting our project. And we have the Anson behind me, and we are a team together in National Taiwan Ocean University. Now, today's topic is the inspiration for Taiwan Maritime Satellite Industry from the YuSat #1. I'm Professor Gao, and beside me is the Anson. Our outline is the Taiwan Maritime Satellite History and the origin of Taiwan YuSat CubeSat. Of course, we will introduce the giant behind us, and the 1U to the 3U YuSat platform of the NSPO. And then we will introduce the AIS and the APIS and the range moment. And finally, we would like to discuss the maritime satellite industry in Taiwan. Taiwan maritime satellite history. History is we have NTOU was the first company to specialize in the designing and the manufacturing of the microwave and the satellite communication products in Taiwan from the 1983, real the maritime distress and safety systems in NTOU for the seaman GMDSS training. As the below, we have the maritime search and rescue security, especially for the maritime distress and safety system in our school. And the component combines of including the EPIB, EMASA-A, EMASA-B, and the EMASA-C, and the long range, the MF, HF, and the short range, the VHF communication system. Of course, we had a never text receiver, and we have some the radar simulation, and some the narrow frequency band receivers. And the origin of Taiwan, the YuSat CubeSat. And in 2016, we are in the conference, a universal conference, about international conference, and from the remote sensing and the satellite and technology, the workshop. And beside me is the Dr. Fang Joe. He is a babysitter for the YuSat satellite. And then now we have a lot of the conference paper and the poster and the journal paper for the YuSat CubeSat. Now is the one of those. Okay, you can see our introduction for the YuSat and some components and the experience and some the construction of the YuSat satellite. And the ICOSI 2016, the conference paper. Now we have to introduce the YuSat all the components and some testing, for example, environmental and the radiation and the vibration testing. And then we have the build out the Earth station, ground station, and then we have all the MGIS for monitoring the AIS signal and the electronic chart for monitoring the electronic signal from the AIS. And then we have the environmental, for example, the seawater temperature and the wind speed, wind direction, current speed, and the current direction from the hydrological on the sea. We want to collect all the data together for the weather reporting, forecasting, and keep the navigational safety and the security on the sea. The study of AI's covered the blind area in the Taiwan Channel is our purpose, the first study. Because you can see, this is each one of the circle is the base station of AIS. Now you can see the vessel traffic density from Taiwan Channel south to Taiwan Channel north. And it's a very large area. It's not enough for AIS base station coverage. On the base station coverage, it only has the 20 to 30 nautical miles. So we have a brown area. As we show you, this is a brown area. So we cannot monitoring the vessels Taiwan Channel from Taiwan Channel or from the south to the north by base station. So we have to use the CubeSat and the AIS payload to monitoring the brown area of the base station from the AIS, the base station, the coverage. That is the purpose from the 1990. We have to develop some base station on the Taiwan near shore, and then we want to monitoring the Taiwan Channel vessels traffic. So our solution is to build up a CubeSat and the AIS payload, and this is a YuSat -1, our first one, YuSat satellite, and this is the AIS, the payload, or the 10 centimeter by 10 centimeter. Then this payload is very useful for long range communication, and this is our CubeSat, a YuSat CubeSat model. Now we have the several Taiwan satellite teams. One project is not only one person can do it. So we have the National Space Organization, NSPO, the Taiwan Space Union, TSU, the National Taiwan Ocean University, then NTOU, and the Taiwan Space Industry Development Association. And we have a communication company, the local company, KY Link, Guanyu. And we have the Mogami, a mobile entertainment company. Then sitting by me, Anson is the general manager. And the Taiwan Taipei Amateur Radio regions. Now they are the giant before us. This is our president, Dr. Xu. She has a lot of the support for our ground station, especially on the YuSat system, the AIS single receiving. Now we have the European. This is the Dr. Liao and his colleagues. And now we have the Guanyu, KY Link, Joe, and Mr. Sen, and the general manager, Mr. Chen, me, and the Fu, and Dr. Lin, and the Xinxiong, Mr. Xinxiong, Mr. Lin. Okay, now this is Anson. Oh, then this is Ransom, and this is Andy, and we have a lot of our partners together. What is the automatic identification system? It's the AIS. You're using this AIS for the maritime vessels monitoring and for the search and rescue and the distress alert system. Now you can see there is an AIS network scenario from satellite to the ocean and to the land, ocean, and the satellite combined together. Then you can combine together from the radio and the internet. So BTS and the MRCC Navy can use the internet and from the sea base station to transmit the signal two-way, and from AIS, you are a whole world communication system, especially in the maritime communication. And the AIS information of a global vessel, you can see it's a very much vessels here. And you can see each one is representing the one vessel. And the different color is the different kind of vessels. So you can see what you keep in the whole world, the vessels, the tracking, and the situation. Now you can see the international, the financial, the transportation, the supply chain. Maybe you can use this data for your local company or international company development and the forecast. Another one is the automatic packet reporting system. We call the APRS. It's designed by Ransom. Okay, APRS is just like land use the AIS. Then you have base station, you have the GPS satellite, and they combine together for the monitoring the land, moving vehicles or person or something, even the animal or some birds, the habitats, the investigation. Okay, you can use mapping system to show any moving activities in the land. Now is the YuSat satellite mission, the nature and the principal specifications. We have the purpose, and we have some of the YuSat satellite, and then it has no military purposes, and the design, building, and the ownership. We will discuss the detail by Anson. Okay. Now you can see we use the UHF channel. You can see the broadcasting, and we are reading the message to the satellite. It's very small. Our satellite YuSat is only 1.5 U. It's very small, so it's very difficult to design and to launch to the space. It's hard to get some message from the Earth because it's very tiny. Now you can see this is a 1U to 3U YuSat platform of NSPO. Now it's 3U, now it is the 1U. Now we are the 1.5U, it's 2U. Now it is all the components designed by ourselves and the local company. So we can have this solution for the Taiwan needs the satellite industry for the future development and some testing. I think it's a good experience to show anyone who is interested for design is 1U to 3U CubeSat satellite. Now we can use or transfer the 1.5U CubeSat to Anson to tell us how to build a real 1.5U CubeSat. Okay, now we would like to introduce our team, and the first one is the.
Hi, I'm Tori from National Taiwan Ocean University. I'm Inju.
Hi, I'm Brian.
My name is Jialing. Hi, I'm Alice. I'm also a member of the team.
Okay, let me introduce the Anson to tell us the CubeSat 1.5U YuSat CubeSat.
Oh, thank you, Professor Gao. Here I'm very great to introduce our 1.5U CubeSat. So before the session, I will tell you, you will see that our members here, and they are focused on the RF region or AS region. So they are very special for this kind of purpose. So our lab is a very original kind of student, but they are working on this 1.5U and even the YuSat X series. And next, you can see the symbol in the model. We can you can see this kind of model are always made in our own ways. We are not buying the cost devices. We are build it from zero to the floor. So it's a very difficult ways to and because it includes some kinds of algorithm inside, especially in ADCS. So we have kinds of algorithm inside it. And thanks for NSPO to provide the related experience for us to engage the space region. Even so, we have the result for the design subsystem and the payloads. So you can see the OPC, ADCS, EPS, AS, TTNC, and also the APIs and the battery system. This kind of system, especially you can see, you cannot buy in the market. So you just see that we build it up from our own experience. And the cellular AS receiver requirement, you can see that because the AS have international standards, so we have to follow up the standards. So the core part is AS FPGA side. So the Killing company is very special on this region. So we use we invite Killing to do this space grade AS. So you can see the I'm receiving the sensitivity is a very good quality. You can see this displays the sensitivity is the -113 dBm is a very good. So you can see our AS is our core part in this lab, in our lab. So we will focus research especially on the FPGA design for the later process and the later products. You can see the NTOU, the satellite ground station. The left part is on our floor, just built up this year, and it will start to track our YuSat-1 signal, because this place is very well to track the signal. You can see that I will show you the real building here. Our campus is very beautiful. I will invite you, if you have a chance to visit here. Our professor will invite you.
Be my guest.
You know, seafood here is very cheap here, and Professor Gao is very welcome everyone to visit here, and he will treat you very
This is very
kinds of food, seafood, right?
Also, this is a very good place for the ground station.
Yes.
Site. It's very well.
Yeah,
very well.
yeah. For you know, our NSPO ground station is in downtown, but this place is located in nearby the shore. So also we have some kinds of mountain here, so we can erase some noise signal. We decided to locate the ground station here to receive the satellite from the east. I just introduced you the ground station, and you can see our lab is focused on the AI system analysis. So we collect maybe thousands or tons of data of AI. So we can analyze the Taiwan's AI data in this lab. So we can provide some AI research to publish using, or can just touch the Professor Gao to get very sensitive data.
Now we have a maritime GIS.
Yeah.
Then you can show an analysis for the maritime big data analysis by the AI or some software. So you can show the whole world the data from the AIS.
You know, Professor Gao also have a course. Is for AI using. So we are starting the AI for AI here is full of very kinds of knowledge. So you can study, or you can do some research here. Otherwise, you can see application for proposed small sat. A number of proposed systems or of commercial satellites constellation. So you can see the LEO communications is the most parts. So everyone doing this communication-based LEO. So also our CubeSat is communication-based. So you can see AI's APIs and TT&C always they are always radio frequency-based. So our lab is focused on AIs, and the next phase we're doing the test for the AIs, the second generation. It's a very high tech the region for the AIs. Why small satellite technology has matured? It's a low cost and much wider access, and you can do some cross storage. Because it has a chip infrastructure and the distributed processing. IT industry big data analytics become profitable, and high development paths. Artificial intelligence. So you see, AI is also the core part that we want to do some kind of logic into our. Just like it's not just MCU, maybe it's more complex CPU. But in our case, we were using the FPGA-based solution because we are thinking that the system maybe can be a fail-safe kind of a system. Recently, I just do some research. I found that Linux has a very good solution to do. Maybe if you have a module, but this module can including 1 or 2 or 3 OS inside. So I can do one can just doing the process, and another one will doing the just wait to be called, and another one just like a watchdog. So if the one system is failed, another will take over. So that's our core. We want to do not just chip. We want to do it to be more reliable. You can see our settlement and the launch here. Yeah, this time we have two CubeSats here in Taiwan for the Falcon 9, and you can see the our CubeSat sends our other shows to provide the service, launch service to us to engage the Falcon 9. So our CubeSat and the NTOU, the CubeSat, we are inside this part, and finally we are the launch is very successful. The maritime satellite industry in Taiwan here, you can see it's very crowded here. So you can see this market or this region. Everyone want to share some their knowledge, not just benefits. So you can see this activity is very active. Here I came to here. Maybe someone will ask me that the status of YuSat 1. Okay, it's our time to let you know that. You can see that our satellite, the signal is not just very well, but we are trying to do the tracking and using the NSPO station as well. You can see the in the picture, you can see the 1.5U record flow and the 3U record flow. So we have doing the same process in the NSPO ground station. And we're also doing the duplex shift correction. You can see we are also tracking the ideal set. We're also doing the two parts. In this ground station, we have two missions. One is tracking 1.5U and another is tracking the 3U. When we receive the signal and we were doing some analysis, because our TD&C, the signal, because the modulation is full of some kind of harmonic. So we have to try hard, and every day and the night we have scheduled the mission to track these kind of signals. So we arrange our members and schedule it everyone and in time to track the signal. Actually, we have got the real signal from Europe and Japan amateur. So you can see that why you set symbol is just like that. So everyone, if you have an interest to analyze our symbol, we are very welcome you to track and analyze. You can see that the signal is from Europe amateur and the Japan amateur. So we match it and say yes, that's correct. So we are very thanks that the Europe and the Japan amateur to provide the signal that they receive the real signal and prove that our CubeSat is alive. The CubeSat made in Taiwan, I think that this data is provided by Dr. Fang Zhenzhou. Thanks for the materials. You can see that the numbers, white Yam say, you have some kind of satellites, but the real you can see the YuSat 1 and the NTOU, the satellite they are launched this year, and later will be the 2U satellite. Taiwan Space Industry Development Initiative. You can see that the material also provided by Fang Zhenzhou. The data is we have some microsatellite development program proposed by NSPO. So, and if you have any interest, you can contact them or join our team we can share some experience with each other. And then our target is always on the AIS development. YuSat 1, the AIS receiver was developed by Keylink. Keylink is very experienced on the radio frequency. Some kinds of the corporate company, I cannot say their name, but they are very focused on this region, and it's a very special. It's a perfect. How to say that? Yeah, the Keylink is based on their mission have some military mission, so they have some radio frequency experience. Oh, okay. You just hear about that. On the next phase, we will start to develop the FPGA-based AIS receiver. Talk with Professor Gao why we want to use the FPGA-based, because we want the system to be reliable and feel safe. Because in Taiwan, the CubeSat fees the cost or the project budget is not that enough. So we have to let our system to be more reliable. So when we discuss these issues, we think we should do that FPGA-based solution. We will use the Linux solution about the space grade. We also focus on the VTEX, the next generation of AIs. This you can see the picture here, AIs and the VTEX satellites. AI satellites is full of space, and you can see you may heard about that Opicom or IMASE.
Yes,
yeah, they are very focused on the AI solution.
Yes.
Yeah. And recently, I have received a mail from the Opicom. They have some interest from the AI's data sharing or others commercial activity. So you can see that this even though that CubeSat is very small and it's just the first mission here in this year, but I think the YuSat X will be a core part in the future in our campus.
Yeah, especially with the introduce the BDES. It's a representative VHF data exchange system. It's a new generation for the maritime communication system, including the search and rescue and the maritime communication and the data exchange, and especially for the environmental protection monitoring. It will be the next generation for the maritime communication system. Now we have started to develop the BDS in Taiwan.
Yeah, Professor Gao is very focused on this region. He's very familiar here. We also know that VTEX, the satellite, VTEX, the protocol, it also provides the packet-based communication, not just exchange data. We can use the VTEX system to engage our packet exchange. So in the ocean, we can doing this kind of communication. So that's our core part in the VTEX system. You can see our new name. Here. YuSat X is for maritime service. Yes, we have discussed with our team here in our lab. The Professor Gao is very support this kind of series. You can see the color parts. We have made some kind of devices with our own. APIs, AIs, ADCS, EPS, OPC, ETC. We have a kind of spec, and this materials. I'm thanks the Dr. Bang Zhenzhou. He support our team to define kinds of spec and to share his experience to support our YuSat to be launched, and finally it is successful. And the related works that involved as VTEX development, including software, hardware, and the upgrade design. So we have a hardware, we have software, and you can see FPGA, MCU, circuit design, power, and radio frequency here. And we have AIS VTEX and GMSK modulation and demodulation. So our lab is very focused on the radio frequency. So Professor Gao also has some inviters to join the course about the radio frequency. He teach us the GMSK and the other spec or other modulation. Yeah, Professor Gao, how can you say something about your AIS?
I think the communication system, especially in the digital communication system, is for the satellite, the modern time. So the digital communication is still have some interesting things and new development from our lab. So we will tell our teams together to study the modulation, the channel simulation, and the decoding and the sound application, especially for the AI and the big data collection, and try to do something to establish some model or some experience, the very experienced protocol to help the Taiwan Maritime Satellite Communication development.
Our name, YuSat X, we are working on the new power system for the 3U or 6U EPS. We have proposed the new design, and finally the devices has worked out, and the function is very reliable, and it can, because YuSat 1 use the single phase waves, And the next generation about the EPS, we will use the multi-phase buck converter to be applied in our EPS. And we are testing it on the way, and we will provide our device, our EPS board to the college student to be evaluated. And in the course, they were doing some experiment. Followed by YuSat series will be the maritime satellite. We focus on this region, and the space-grade components will be designed in. And we also cooperation with the NTOU, Professor Zhuang Zhiqing. Professor Zhuang is very familiar with this kind of region. We also heard about the furnace, the CubeSat. Also, we have some other people. I see the list here. The Hennigan, you are here, right? From outer shoes. And the outer shoes always also provide the launch service here. And next, we were to be the #1 here in Taiwan. What are you talking? So everyone will say you want to be the #1. Yeah, we want to be the #1 here in AIS region. Yes, that's our target. To deploy the YuSat X maritime satellite network or constellation, that's our target and our objective.
Our responsibility.
Thank you very much.
Okay, maybe you can show the video. Especially, we would like to thank Dr. Brown and Dr. Lin. They are all of us the babysitter. You say the assistant, the babysitter. Okay, now we can show you the video from our teamwork.
YuSat卫星呢，它主要呢是针对我们所谓的 APRS 还有 AIS， 就是所谓的这个车辆或者是这个鸟禽动物或者是人员的追踪，大面积的追踪。当然，目前有很多的GPS 追踪方式都可以透过地面的4G、3G 来追踪。但是如果你在大面积范围上面，并不代表很多的机还能够收到信号。那你唯一的方式就是要靠着这个卫星的方式来做大面积的追踪以及接收信号。所以很多的船舶或者是运输业，很多都是在全球在跑。那么在这个茫茫大海里面呢，会遇到很多的死角，信号死角。所以透过我们的卫星来串联一切的这个船舶以及运输业或者是鸟禽追踪，尤其是目前很多的这个带来 H5N1 这一类的候鸟的带来的疾病呢，我们希望是透过这个卫星的方式来追踪它。目前你所看到的板子呢，电路板呢，是我们的所谓的陆上位置自动发报的接收板。那信号呢，把它透过地面这个在个人身上或者在物件上面，然后发射到卫星透过这个板子来接收。收到了以后呢，本身资料呢会储存起来。那么它所收集的数据呢，在大概每一圈在绕地球97分钟的时候呢，都会有经过地面站。那地面站呢，我们在世界上面有许多的一些业余无线电的地面站可以来接收这个信号。这个通信键盘主要负责的任务，它就是把接收到刚刚所讲的一些不管是海上船舶或者是鸟禽的资料。接收到以后转由电脑板，电脑板会转发到地面站需要转发地面站就得透过这个通信板。那同时这个板子完全是由我们自己的设计，能够最主要呢能够推广，能够大量来使用，还有让它普遍性，能够让高中或者是学术界、大学都能够透过这个板子来大量采用这个以学得更多的卫星的设计知识。
那 AIS 呢？它是一个船舶标示系统的一个缩写。那么它主要的用途是用在船只的位置的标志，所以他们在海上彼此之间的时候，它可以显示在海图上他们的船跟船之间的彼此位置，以用来避免船舶彼此碰撞。因为 AIS 这个 sensor 它的体积很庞大，所以要一定以上的吨位的船只才会安装。那它的发射讯号会有一些死角，所以我们的卫星上去是要弥补它的这个盲区，使得这个死角变得更少，然后可以收到更多的定位船只的讯号。
这个就是我们在做姿态控制的时候，我们用 HISTK 来做所谓的模拟。那因为模拟的过程里面可以让我们知道说，我们在设计的单板电脑的时候，那我们的一些参数要怎么做。也就是说，它本身是一个卫星电脑加上一个姿态控制，所以用这样的方式，我们就可以知道说，我们的卫星在太空里面的所有的姿态。所得到的 sensor 的状态资料，那我们去做相关的演算法，然后来去做所谓的校正，然后后来我们再透过所谓的头壳，然后再进行所谓的稳定的一个阶段。所以各位看到说，这就是 HISTK 所做出的模拟。
那在这里呢，我们主要测试的就是所谓的辐射太阳中充满了辐射电离子，那么会对于我们的电路做成严重的破坏，尤其对我们的半导体晶片会有严重的破坏。那看起来目前已经测试完毕，而且灯还在继续闪，就代表说它经过了U60辐射的照射以后仍然存活，所以在我们的太空使用是可靠性很强的哦。那针对这些锂电池呢，你可以看得到距离跟一般的板子的距离不太一样，它是用最强烈大概高于板子的辐射照射的5倍的这个辐射量，所以它目前为止呢，或许我们需要回去做各个电池的它的实验。
You can see this is our step for the YuSat members in NSPO. So you can see many kind of system on the hands, and they are starting and learning or testing some kind of system. Okay, I will let you know what kinds of stuff that they are doing.
We are doing radiation test for the different type of board.
We do TTNC and APIS test. Here is a APIS transceiver, and we can make some radiation tests with APIS. I'm very happy when I can keep it in my hand.
You said good!
Thank you for a very interesting description of the YuSat project and also for your future plans for AIS.
Yes.
Since you mentioned you are currently working on development of follow-on to YuSat, what is your plan for deploying more satellites for AIS studies, and how many satellites do you believe you will need to provide the type of tracking service that you would like to provide?
Okay, thank you, Lauren. We have a new plan this year for the next YuSat satellite communication. We combine the AIS and the camera together for the AIS, the single receiving, and the see the situation and the weather on the sea combined together for our new satellite design and development. Now the project is undergoing. Of course, if we will have the chance or the financial problem is not a problem. We want to install the 36 satellites for the real constellation for the business model. Thank you.
Okay. Well, as a follow-on, you mentioned that you plan to downlink image data. Now, will there be problems with the data rate, especially over UHF, if you plan to download images?
Yes, I think the data rate is not enough, but we will extend the data rate from to 9,016, and maybe higher is another research. Maybe we try to enhance the signal, the strength, and the data big rate to share the bandwidth and combine the data together.
Okay, thank you. We have a question from the audience. So if one has developed new space technology and wants to commercialize it, who in Taiwan is the right point of contact?
Yes, I think the new generation will be start from this first YuSat-1 launch the mission. Now we just begin to develop the maritime communication system for all over the sea. Just the beginning.
So in terms of funding, are you looking at public sources such as Ministry of Science and Technology or NSPO, or are you looking at private venture capital or, for example, angel investors?
Sure. We now have a new investment. We are considering because our companies, the capital is not that big. So the investment, the angel fund or from the government-based funding, we will think is the best way to do it in our company, because our capital is too small. So using the company to invest us, I think that's not a very good way. Thanks, Lauren.
And here is Christine features. If you want to need some technology support, you may contact our school, or you can see my name on the website, National Taiwan Ocean University. Thank you.
I think that's helpful for any of you who are interested in commercializing space technology. So what do you think is the right sort of opportunity for collaboration between industry and academia for space technology in Taiwan? What are there opportunities for, and how can industry and both universities collaborate in this respect?
Yes, the team together to develop the YuSat satellite, the new generation. We combine the local company, and we have the new idea for combine the AIS and the camera. So we have find out the general manager Chen and the KY Link and the general manager Chen 2. Then we'll combine together to develop the newest, the YuSat-X satellite.
Thank you very much for your response. Are there any other questions from the audience? Please raise your hand or unmute yourself.
Okay, and Christine got my message. Will contact us. Thank you very much.
Just as a reminder, we still have 2 more sessions in our CubeSat webinar this afternoon, starting from 3 p.m. Taiwan time. We have 2 speakers from Finland on talking about the Suomi 100 CubeSat, and also on using CubeSats for lunar mission activities. So please join us at 3 p.m. So thank you again to all our speakers, and to all of you for attending, and wish you all a very good day and a good weekend. Thank you.